In this video series we will cover a book, Hands-on Machine Learning with Scikit-Learn, Keras and TensorFlow. This is a very important book when it comes to machine learning, and the chapter 1 of this book is more theory related, so I want to start it from chapter number 2. In this video I will cover the chapter number 2. In chapter 2 we have mainly 8 main points. The first one is the look at the big picture, then the get the data, then discover and visualize to gain insights, then prepare the data for the machine learning model, then select a model and train it. After training it, we have to tune our model, then present your solution, then launch it on any server. Okay. Before diving into these 8 points, I want to tell you this is the dataset of housing California based on 1990 census. Okay, this is a real dataset. We work on real dataset because real dataset are messy, requiring pre-processing, exploration and careful handling. Okay, and our target is to predict the median house value in $USD. Okay, now the first point is the look at the big picture. This point is more theory related, in which we mainly focus the 3 to 4 things. Okay, I want to make a markdown. Okay, in which we mainly focus on the 3 to 4 things. The first one is the objective, then the second one is the problem type, third one is the task, and the last one is the performance measure. Basically we frame our problem, what is our objective, what is problem type, what is task, and what are the performance measures. Our objective is to predict the median house value for each district in California. Okay, and our task is the regression task, and our problem type is supervised learning because we have a label given in this data. And our performance measure is the RMSE. It is a very common and useful. Basically it gives me the difference between the predicted and the actual ones. Okay, hope you will get it. Let's move to the second point, the get the data. Okay, in this point you simply load your data in the VS Code. So I give you file in description, the housing.csv. You just download this file and paste it in the directory of the VS Code in the same folder where you're running your code. Then simply use the pandas and give the name of your dataset, let's say housing, and pd.read CSV and your dataset name. Okay, using this your dataset is successfully loaded in VS Code. Okay, now you can also download from Kaggle or OpenML or many more websites. It's open source. Now take a quick look on my dataset. Let's say I want to see a first few rows of my data. I simply use the head. It will give me the first 5 rows of my dataset, as you see. And if I want to see the basic info of my data, I simply use the info. Okay, it will give me a lot of things, the 10 features with data type and with known null values. I observe one thing, the total bedrooms have a many null values. It has a 20,433 out of 640, and the 9 numeric values, and the last one is non-numeric value. You can also see in the Excel file, this one is non-numeric. Hope you will get it. Okay, now I want to see the statistics description of my data. I simply use the describe. Okay, it will give me the description of my data in statistics point of view. Okay, I observe one thing here, the median income has a range between 0.5 to 15, and the median house value, this one, has a range between 15,000 to 5 lakh. So it's a huge difference. We will do a scaling in further code, because machine learning does not work on these kind of huge difference. We have to scale it into a specific range like 1 to 5 or 0 to -2 and something like this. Okay, hope you will get it. Now for understanding our data in more detailed, I want to make a histogram of my features. Import matplotlib and my dataset dot hist bins equal to, let's say, 50, and the fixed size of okay, it is working. This is the histogram of my dataset of all the numeric features, in which I observe two things: the columns of total rooms, bedrooms, population and household are rightly skewed. So in further code we have to set it, otherwise our model does not predict well. Okay, after this I think we have to go to the splitting. We have to split our data into training and testing. In the beginning of our machine learning, we mostly use the random split, but in this case we have to use the stratified shuffle split, because it is a very important data set, and we have to ensure that the rich people gets the expensive house and the poor people get the poor house according to his demands. So if I use the random split here, then it will not make sure the demands will be fulfilled. I want to use the stratified shuffle split. For using this, I simply want to make a column of new column income cat, and use my pandas to cut my median income, and give the labels and the bins equal to, let's say, 0 to 1.5 to 3 to 4.5 to 6 to infinity. Okay, and labels equal to, let's say, 1, 2, 3, 4 and 5. Okay, before using the numpy, you have to import it. It is working. Our column is successfully created in our data set. I want to show you. This is our column income cat. It's successfully created in our data set. Okay. now I want to apply the stratified shuffle split on my data. I simply import the stratified shuffle split. And okay, I want to make a variable of let's say splitter and use my stratified shuffle split. And n split equal to 10, test size equal to 0.2, means 20, and random state equal to 42. And I want to store my training and testing data into two specific variables. I want to initialize the two variables, trend index and the test index, in the splitter. And split with the help of two things. The first one is my data set and the second one is my new column. My new column is income cat, and close my for loop, and I want to make two variables, trend set and the test set. In training, I simply use the location function to locate my training data into training set, and in testing, same as I use the location function to locate the testing data into testing set. Housing.iloc, I lock the trend index, and housing.iloc, I lock the test index. Okay, it is working. I think it is working. Our splitting is done. Okay, now at this stage your first two step is successfully completed. Now I want to explore the data and gain insights. Okay, I simply, first of all, I want to make a scatter plot of geographical data. As we all know, we have a geographical data in the form of longitude and latitude. I want to make a scatter plot of these two to gain the insights. Before moving to the exploring, I want to make a copy of my data. My trend set dot copy. Okay, it is done. Now I want to make a scatter plot, and simply use the housing dot plot the kind equal to scatter, and x equal to longitude and y equal to latitude. Okay, and use the grid equal to true. Okay, scatter is not defined. Just a minute. Okay, it is working. Just if your code is not working, just restart the kernel, it will be working. Okay, our scatter plot is here, but it is not clear as I want. I want to reduce the overlapping. Simply use the alpha equal to, let's say, 0.2. Now it's better. So this is our scatter plot. Hope you will understand it. Okay, after this I want to make a heat map for a better detailed scatter plot, because in this I'm not understanding anything what is doing here. I want to make a colorful heat map. Simply copy this code and made a few changes in this code. Just a minute. I simply I just want to use the two columns, two features, s equal to the population and just a minute, population, and give the label equal to population. Okay, and want to use a one more column, median house value, c equal to median house value. And for making it more clear, I want to use a C map equal to, let's say, jet, and the color bar equal to true, and legend equal to true, sharex equal to false, and fixed size equal to let's say 10 and 7. Now it will working. Just a minute. Okay, it is working, but one problem. Just a minute. Okay, I organize it into a good manner. Okay, this is the scatter plot heat map of our data set. I give the quick summary of this. The red means the expensive, the blue means the cheap. Okay, the red in this chart, this one. Okay, I want to take a picture and explain it more deeply. Let's take the picture. Okay, the red one, like this area and this area, means the expensive area. Okay, and the blue, like this, all the area, this one, and this one means the cheap, and the larger circles indicate the area with larger population. A larger circle, like you can say this circle, and there are a few more. This circle indicates the area with larger population. Okay, hope you will get it. Now I think I look for a correlation. Correlation is a technique in machine learning in which you find the most related feature to a specific feature. Okay, first of all I want to make a correlation on my full dataset, then for a specific column. Okay, before calculating the correlation you have to convert your features into numeric, otherwise it will give you error. I want to make the variable of housing numeric. and in which I convert my data into numeric. Select the type include only numbers. Okay, now I simply use the correlation housing numeric dot correlation, and I want to store it into a specific variable. Just a minute. Let's give the name of correlation matrix. Okay, it is working. Now if you want to see the correlation of a specific column, like for example I want to see the correlation of median house value, I simply use the go matrix and my column name the median house value, and sort value is ascending equal to false. It will give you the correlation of your feature. You can see it, the median income the most closest feature to the median house value with 0.68, then the total rooms with 0.13, then the housing median and the 0.108, then the household, and many more. Hope you will get it. Now I want to explain you another concept of machine learning, that is feature engineering. It is very important concept in machine learning in which you make a feature on the basis of existing feature. Okay, I want to create a 3 new feature. Let's say give the name of first one is room per house, and the second one is the let's say bedroom ratio, and the third one is let's say people per house or person per house. Okay, in room per house I want to add the 2 features, the total rooms and the total and the households, and simply use, just a minute, I just copy it and okay, now in which I use the 2 features, the total rooms and the household, and in which I use the total bedrooms and the total rooms, and in which I want to use the population because I make a feature of people per house, so obviously I use population and the household. Okay, it is created in our dataset. If you can see, you simply use the housing info. You can see it, the 3 new columns, 3 new features are successfully created in your dataset. Hope you will get it. This is called feature engineering. Okay, now at this stage your first 3 step is done. Now I think we will go for preparing the model for machine learning. It is a very crucial and important step in any project. Okay, I want to give the comment the preparing the model for machine learning. Okay, in which first and the most important step is to separate the features and the labels. Basically, features are those that is used to predict your data, predict your target. In this case, our target is median house value. So except median house value, all the columns are our feature. Okay, and target are obviously the median house value is our target. So I want to make a two variables of features and target. Let's say I give the name of features. Okay, I make a variable of feature and target, and in feature I simply want to drop only one column from my training set. Drop my target column, that is median house value, and x is equal to 1. And in target I copy only one column, that is my target column, from my training data and median house value and dot copy. Okay, it is working. So our feature and target are successfully separated. Okay, now as we all know, we have a lot of missing values. As you can see, 16,512 out of almost I think 21,000. So first of all, we have to fill all the missing values. We have many techniques to fill the missing values. In this case, I think so the simple imputer is the best technique. Let's impute the simple imputer. And I want to store it into a variable of imputer, and strategy equal to, I want to fix my missing value with the median. Okay, and now before apply the median on my values, I have to convert it into a numeric. I want to create a variable of housing n, housing num, and housing dot select type include your np dot number. You can also use simple numbers here, but this is more efficient way. Now simply fit in imputer dot fit your housing num. Okay, it is working. Now it's time to transform it. I simply use the imputer dot transform and transform my housing num. Okay, it is successfully filled using median. Now I want to store it into a variable. Let's say give the name of x. Oops. Okay, it is working. Our filled value, missing value is successfully filled. Okay, now we have a non-numeric column in my dataset. As we all know, the ocean proximity. We have to handle it because machine learning does not support the numeric, non-numeric values. There are many techniques. I want to use the one-hot encoder. Before using the one-hot encoder, I want to store it into a specific variable. Let's say give the name of housing category. Sorry, housing cat, and the store my feature names the ocean proximity. Okay, and okay, to store I want to see the first 10 rows of my feature. Okay, it is successfully working. Now I want to apply the one hot encoder in this. I simply import the one hot encoder from Scikit-Learn dot preprocessing, import one hot encoder, and store it into a variable of encoder, and apply it. Cat encoder dot fit transform your housing cat. Okay, it gave me error. I think you have to store it into a double brackets. Now it will be working. Okay, it is successfully converted into a numeric. Stored it into a variable of let's say housing cat 1 hot. Okay, done. After this, now as I tell you in the beginning of code, we have a range between the 0.5 to 15 and the 15,000 to 5 lakh. So we have to set a specific range. So for this I have to use the scaling. We have a different techniques in scaling like min-max scaling, StandardScaler, and many more. In this case I think so the standard scaling is the best technique. I use the Scikit-Learn dot preprocessing, import the StandardScaler, okay. Now simply fit and transform your StandardScaler into a numeric values housing num. Now simply store it into a specific variable. Let's say give the name of housing num std scaled. It is working. Now at this stage our pre-processing is done. Now I want to make a pipeline to combine all the pre-processing into a single pipeline. And okay, from Scikit-Learn dot pipeline, import the pipeline, and also want to import the column transformer. Scikit-Learn dot compose, import the column transformer, and want to make a variable of numeric pipeline in which I use my pipeline and my, in case of numeric I think first I want to use the imputer, and then I want to use the scaler, okay. In imputer I simply use the simple imputer strategy equal to median. Simple imputer strategy equal to median, and in scaler I simply use my StandardScaler, okay. Now I think it is done. Just okay, it will give me error. Okay, simply use the comma here, then your code will be done. Now I want to make two more variables, numeric attributes and cat attributes. In numeric attributes, I want to store the list of all my numeric columns, list of housing uh, columns, housing numeric columns, okay. And in this I simply store the ocean proximity, my non-numeric column. Okay, after this I want to use the column transformer to transform. I want to make a variable of full pipeline, and in which column transformer, and in column transformer I use the numeric and the non-numeric. In numeric I use the numeric pipeline and numeric attributes. Numeric pipeline and the numeric attributes. Close the bracket, comma, and in non-numeric I use the technique to handle non-numeric, that is one hot encoder and the cat attributes. Now I think it will be working. Okay, it is working. Now I want to store it into a final and in a one variable of prepared, and use my full pipeline dot fit transform my data, that is housing. It is done. Basically, before this we use a lot of techniques for handling missing values, for handling numeric values, non-numeric values. So in this step I just combine all the techniques in a single pipeline that is used to so that will use in further code in an easy way. I just write the prepared and all the pre-processing will be working. Okay, now at this stage your first 4 point completed. Now select a model and train it. First of all I want to select a model. Let's say there are many supervised learning models. I want to use the linear regression. Simply import the linear model, import the linear regression and store it into a, let's give the name of model 1 and the linear regression and model dot fit my all the data in the form of prepared variable and my labels, sorry, my target. Okay, model 1, it is working. Now I want to see how good our model is working, what is the RMSE score of my model. I simply use the Scikit-Learn.matrix, import the mean, squared error. And before using it, I have to predict my model. Let's say give the name of prediction 1, and in which I use my model 1 dot predict my prepared. Okay, after this simply use the RMSC and np dot sqrt mean squared error and your target and your prediction. What is your target? Median house value, and your prediction 1. Now simply print it RMSC of linear regression RMSC. Okay, this code is good, but I need a more good score, so I have to use another model. Let's say I want to use the decision tree regressor. Scikit-Learn dot tree import decision tree regressor and store it into a model 2 and your decision tree regressor. And simply model 2 dot fit your prepared and your target. It is working. Now I want to see the RMSC score of this model. I simply use the model 2 here, prediction 2 here, and prediction 2, and also give the name of RMSC 2. Okay, it is working. It will give me the 0.0. Basically, RMSC score is the difference between the predicted and the actual ones. So this model, the decision tree regressor, is far better than the linear regression in this case. Okay, after finding your best model, that is as we all know, okay, our best model is decision tree regressor in this case. And now you have to tune your model. So for tuning, it will take a lot of time. This is a code of tuning, and this is in which the parameter grid is a fixed code. You can use this grid in a lot of models, and then you simply import your random forest and store it into a specific variable forest reg. Then use your grid search, in which you simply use first the random forest in the form of forest reg, and then the parameter grid, the fixed code, and CV equal to 5. In this case I set the CV equal to 5, and scoring kind of the negative root mean squared. It means negative RMSC. Okay, I give the name of negative RMSC. Okay, and return trend score equal to true, and fit with prepared and target. Then it will give me the output of random forest regressor. It means the random forest regressor is the best model that you can use. Now At this stage your uh, first 7 step has been done. Now it's time to launch our model. Okay, for launching in the form of application or website, simply use the pickle or job lib. In this case I use pickle. You simply import the pickle and then save the file in the form of pickle. When your file is saved in the form of pickle, then you can see it. This is my pickle file. Okay, now on launching it on a Streamlit, I have this code of Streamlit. I simply run this code, run Python file. Okay, it is working. Now you just open your folder where your pickle and man file is stored, and press the shift and right click and open with the PowerShell here, and at here you simply run the command streamlit run app.py. Okay, as you can see, this is our model and it is successfully working. Thanks for watching. In next video we will study about the chapter number 3.